Welcome back. This will be our final submodule on trigonometry. We'll look at trigonometric equations here. I'll show you a variety of types of questions that I feel are representative of things you might see on the CLEP exam. We may be using inverse trigonometric functions in this case. We might also be drawing triangles to help us out. So let's start with something straightforward. This is probably too easy for the CLEP exam. You should certainly know how to do this question. So I would like sine of 1/2. You can always try to draw a picture to give you some idea of when this happens. You can also draw our favorite 30, 60, 90 triangle. So in this case, we know that what kind of angle will give us 1/2? Well, it looks from this picture like 30 degrees, because that will give me opposite over hypotenuse as 1/2 over 1. So also known as pi over 6 in radians. You could also solve this directly by just using arc sine. Which is pi over 6. Now keep in mind that there are other choices for this. We could also have used this value here. This value here. So that would be pi minus pi over 6. So 5 pi over 6 would also be a solution, as would any 2 pi multiple. So if I want it to be totally complete, I could say that theta is equal to pi over 6 plus 2 pi k for an integer k, or 5 pi over 6 plus 2 pi k for an integer k. So this takes account of the periodicity of the sine function. How about now? Let's look at cosine of theta over 2. And I want that to be equal to 0. So let's draw a picture of cosine. So something like this. So we see that cosine is equal to 0 at pi over 2, 3 pi over 2, also at minus pi over 2. So what does this tell us? So cosine of, let's say, theta equals 0 if theta equals pi over 2 plus pi times k. So then this tells me that I need theta over 2 to be equal to pi over 2 plus pi k. So theta should be equal to pi plus 2 pi k. So fairly straightforward. If I plug in k equals 0, then I get pi, 3 pi, 5 pi, also minus pi, minus 3 pi, and so on. So for these types of questions, again, I think it's very helpful to have some idea of how to plot the functions, which you will get practice at from working it through our supplemental readings and our exercises. So here's a question I really like, because it goes back to really understanding what the triangular definition of these trig functions are. So I am saying, suppose that sine of theta equals 3/5. I want you to tell me what tangent of theta is. So the way I would like to do this is say, well, what is sine of theta? It's defined to be opposite over hypotenuse. So the picture for the triangle is something like 3 and 5. But what is tangent of theta? It's opposite over adjacent. So 3 divided by the adjacent. But unfortunately, the adjacent doesn't appear to be given. It's an unknown side of this triangle. But I do have a tool in my arsenal that will help me compute what the adjacent side is. So the question is, given two sides of a right triangle, can I compute the third, and how? Hopefully you understand that the answer is yes, and I can use the Pythagorean theorem. So I'll call this side B. So I know from the Pythagorean theorem that 3 squared plus B squared equals 5 squared. So 9 equals B squared (9 plus B squared equals 25). So B squared equals 16. So B is equal to 4. So I know that the adjacent side is 4, and I get the tangent is equal to 3/4 in this case. So why did I suggest doing the problem like this? Well, the alternative would maybe be the following. First, take arc sine of 3/5 to get theta, and then compute tangent of that. So this is equivalent to saying compute tangent of arc sine of 3/5. And you may even see the question phrased like this on the CLEP exam. And for these types of questions, where they ask you to evaluate an original trig function at an inverse trig function, really the best tool in your arsenal is to draw the triangles and remember the basic definitions of the trig functions. So let's look at one more question that doesn't necessarily require us to do many computations, but will test our theoretical understanding. So the question is, how many solutions does tangent of 3 theta equals 1 have in the interval 0, theta in the interval 0 to pi? So how could we do this? Well, let's first draw tangent of theta on the interval in question. So I have an asymptote at pi over 2. Okay, so here is the function just tangent of theta on that interval. And you can see I have this, I'm going to cross the line x equals 1 one time. So on that interval, I have one solution. So what is doing this 3 theta do? Well, it's going to speed up my rate. So the picture in this case will be something like this. So if I plug in theta equals pi over 6 into tangent of 3 theta, that'll be like evaluating the original function at pi over 2. So I'll have an asymptote there. So here is one iteration. And then I'm going to have another asymptote at where? So let's see. Here's where the next asymptote will be, pi over 2. And I'll have another one the picture looks something like this. So now I ask the question, how many times does this plot cross the line x equals 1? Or rather, y equals 1. And I count. Well, it crosses it here, here, and here. So actually computing these values is not something I'm being asked to do. And it might not even be that obvious. I mean, we could probably do it because we know that tangent of theta equals 1 when theta is pi over 4. So we could actually compute the values at which tangent of 3 theta equals 1 on this interval. For example, one of them will be pi over 12. Will be one of them. And then there'll be two others. But really for this question, they're not asking you about that. They're asking you to understand, what does the picture of tangent of 3 theta look like? Well, you want to understand A, what the picture for tangent of theta looks like, and then what is the role of putting this multiplier of 3 in the argument. And what that does is it speeds up my period. It makes me repeat more quickly. So instead of seeing one period in the interval 0 to pi, I see 3 periods, which means I have 3 places where I have this solution. If you like using your graphing utility, and you should have at least some desire to do this since it's going to be on the exam, practice plotting this. Set your window to be 0 to pi and plot tangent of 3 theta. And you'll be able to see exactly what's going on. I, of course, want you to also be able to do these kinds of sketches by hand. But using your graphing utility, in addition to the textbook and our questions, will give you another way to build understanding on these concepts.